Good morning, students. Today I am going to discuss about the topic relations and functions. So, what is the definition of a relation? Let A and B be two non-empty sets. Non-empty sets. Let A and B be two non-empty sets, then a relation R from A to B. Then a relation R from A to B is a subset of A cross B. Let A and B be two non-empty sets, then a relation R from A to B is a subset of A cross B. In the previous we have discussed the subsets, the Cartesian product of AB. What is the Cartesian product of AB? The Cartesian product of AB is equals to this added pair, okay, such that A belongs to A, B belongs to B. So the Cartesian product of AB is an ordered pair such that A belongs to A, B belongs to B. So here R is a subset of A cross B. R is a subset of A cross B. So the definition of a relation is A and B should be a non-empty sets. When a relation R is defined from A to B is a subset of A cross B. A cross B is nothing but the Cartesian product AB, the added pair AB such that A belongs to A, B belongs to B. Let us illustrate with an example. Okay. Let A is equals to 2, 5 and B is equals to 4, 7. We can find the Cartesian product here now. We can find the Cartesian product. What is the Cartesian product? A cross B is equals to 2, 4. 2, 4. In the previous year we have discussed about this. 2, 4. 2, 7. So 5, 4, 5, 7. 2, 4, 2, 7, 5, 4, 5, 7. We can define the relation R. Define a relation R as A is greater than B. We can define a relation by this Cartesian product as A is greater than B. So is it greater than B? This one is A, this one is B. Is A is greater than B? This one is smaller than B. A is smaller than B. Here also A is smaller than B. This one A is greater than B because this one is A, this one is B. So 5 is greater than 4. Here, so A is less than B. So what is R? R is equals to 5, 4. Only these elements satisfies. According to that condition, as A is greater than B, none of the elements are satisfying except 5, 4. So, relation is let A and B be two non-empty sets. Then the relation R is defined from set A to B is a Cartesian product of A cross B. So, A cross B is equals to an ordered pair AB such that A belongs to A and B belongs to B. So, by this we can find the Cartesian product. Okay, we can, because R is a subset of A cross B. This is a subset of A cross B now. In the first year also we have discussed subsets, sets, power sets and all. So R is equals to 5, 4. As A is greater than B, we can find the ordered pair. That is equals to 5, 4, 5, 4. Next one is types of relations. Next one is types of relations. Types of relations. First one. First one is reflexive. Reflexive relation. Reflexive relation. We should know the definition. A relation R and a set A is said to be reflexive if A belongs to A comma A belongs to R. This is very important for this session now. What is reflexive relation? What is the reflexive relation definition? A relation R. A relation R on a set A. A relation R on a set A is said to be reflexive. A relation R on a set A is said to be reflexive if for R A belongs to A comma A belongs to R. This one is very important. So a relation R on a set A is said to be reflexive if for R A belongs to A comma A belongs to R. This is the definition of a reflexive relation. Here, for R means for R. Also, we can use for every. For every. This one is A comma A belongs to R implies A is related to A. A is related to A. A is related to A. So, what is the definition of a reflexive relation? A relation R on a set A is said to be reflexive if for all A belongs to A comma A belongs to R. We can give the examples of a reflexive relation. It is coming in the examination, okay? The first one is relation parallel to is a reflexive relation. A relation parallel to is a reflexive relation because every line is parallel to itself. What is the relation parallel to? Parallel to is a reflexive relation because every line is parallel to itself. For example, this one is A. The line A is parallel to itself. That is, the line A is related to itself. The line A is related to itself. The line A is related to itself. So it is a reflexive relation. Reflexive relation examples, parallel to is a reflexive relation because every line is related to itself. Next example, divides 2. Divides 2 is also a reflexive relation. For example, 2 divides 2. Is it right? So here 2 is related to 2. So 2 divides 2. We can give this definition. Divides 2, we can give the example. Okay, 2 divides 2. Because it is a reflexive relation. So for example, next A is equals to A is equals to 1. We can find the Cartesian product. What is the Cartesian product? A cross A. For example, A is equals to 1, 2. We can find the Cartesian product A cross A. It is equals to 1, 1, 1, 2. So, 2, 1, 2, 2. Okay. So, we can define the relation of by this Cartesian product 1, 1, 1, 2, 2, 1, 2, 2. Is it a reflexive relation? Yes, it is a reflexive relation because the elements 1, 1 and 2, 2 is there in the set R. 1, 1, so 1, 1, 2, 2 is there since 1, 1 belongs to R and 2, 2 belongs to R. Therefore, it is a reflexive relation. Okay, you understood that? These are the examples of a reflexive relation. A set R is said to be reflexive if for all A belongs to A, AB belongs to A. Then only it is called as a reflexive relation. Examples of a reflexive relation are parallel to, also we can give, and divides to. By these examples, R is equals to 1 1, 1 2, 2 1, 2 2. It is reflexive because 1 1 belongs to the set R and 2 2 also belongs to the set R. Therefore, it is a reflexive relation. Next one is symmetric. Next one is symmetric relation. Okay. Next one is symmetry. Relation are on the set A is said to be symmetric if for all AB belongs to A, AB belongs to R, implies BA belongs to R. This is very important. You should know this statement. Then only we can solve the examples. It is coming for examination also. This statement is very important. What is the definition of a symmetric relation? A relation R and the set A is said to be symmetric if for all AB belongs to A. These elements should be there in the set A. After that, AB belongs to R. These AB should be there in the set R. Say there in the set relation R. BA also should be there in the set R. Then only it is called as a symmetric relation. Examples. Here also we can give parallel also. Parallel is a symmetric. Parallel to is symmetric. How it is symmetric? If we consider two lines, okay. Consider two parallel lines. We can say that A is parallel to B. Is it right? Implies B is also parallel to A. If A is parallel to B, implies B is parallel to A. Then only symmetric relation satisfies. According to this, AB should be belongs to R. Then BA also should be belongs to R. Then only it is called as a symmetric relation. So AB belongs to, AB is parallel to B, implies B is also parallel to A. Next one is perpendicular to. Perpendicular to is also symmetric. You can give examples, okay. This A and this B. A is perpendicular to B, implies B is also perpendicular to A, okay. These also examples we can give as symmetric relation. Is it a symmetric relation? A is taller than B. Is it symmetric? If A is taller than B, then B must be also taller than A. No, how could be possible? A is taller than B, then B need not be a taller than A. Therefore, it is not symmetric. Taller than is not symmetric. If A is taller than B, B should also be a taller than A. So, this conversation is not possible. So, next example. A is a brother of B. If A is a brother of B, B should also be a brother of A. No, it may not be possible because B should be sister of A also. Is it right? If A is a brother of B and B may not be a brother of A. It may be a sister of A. So, it is not a symmetric relation. We can give the examples as A is parallel to B and B is also parallel to A. Similarly, perpendicular to is also a symmetric relation because A is perpendicular to B and B is also perpendicular to A. A friend of A is a friend of is a symmetric relation. If A is a friend of B, B need not be a friend of A. Is it right? It may not be a friend of A. This is also not symmetric. So A is a friend of B is not symmetric. A is taller than B is also not symmetric. A is a brother of B is also not symmetric. For example, A is equals to 1, 1. So you can give A is equals to 1, 2. We can define the relation R 1, 1, 1, 2. So 2, 1. So 2, 2. Is it a symmetric relation in this R? Yes, it is a symmetric relation because since 1, 2, this 1, 2 belongs to the set R implies 2, 1. 2, 1 should also be there in the set R. If 1, 2 belongs to the set R implies 2, 1 must be belongs to the set R. Then only it is called as a symmetric relation. Because according to the definition, what is the definition? Relation R and the set A is said to be symmetric if for all AB belongs to A, AB belongs to R implies BA should also belongs to R. Then only it is called as symmetric. If 2, 1 belongs to R means 1, 2 should also belongs to R. Then only it is symmetric. So this is the examples of a symmetric relation. Because 1, 2 is there in the set R and 2, 1 is also there in the set R. Therefore, it is a symmetric relation. You understood that? First, we should know reflexive, then symmetric, then next one is transitive relation. What is transitive relation? Transitive. So transitive relation. We should know the definition first. A relation R and the set A is said to be transitive. A relation R and the set A is said to be transitive. If for all A, B, C belongs to A, B, C belongs to A, B belongs to R, and BA belongs to BC, BC belongs to R, implies this AC should also belongs to R. You should know the definition thoroughly, then only we can do the solve the problems. We can solve the problems. It is coming for 3 marks, and in this chapter we should know this is the basic. Okay. So a relation R and the set E is said to be transitive if for all ABC belongs to AB belongs to R, BC belongs to R, implies AC belongs to R. So we can give the examples. So many examples we can give. Which is the first example? Parallel to is also a transitive because if A is parallel to first one, which is parallel to, we can consider 3 lines. Okay. So here A is parallel to B and B is also parallel to C, implies A is also parallel to C. Okay. So parallel to is a transitive relation because A is parallel to B, B is parallel to C, implies A is parallel to C. So this is the definition we should know. For all ABC belongs to A, AB belongs to R, BC belongs to R, implies AC also belongs to R. We can give the example parallel to because A is parallel to B, B is also parallel to C, implies A is parallel to C. We can give the examples. Greater than is also transitive. greater than is also a transitive relation. Greater than is also a transitive relation. For example, if 5 is greater than 4. If 5 is greater than 4 and if 5 is greater than 4, we have to start from 4 itself. 4 is greater than 3. If 5 is greater than 4 and 4 is greater than 3 implies what should we have to write? So 5 is greater than 3. Is it a transitive relation? Yes, it is a transitive relation. 5 is greater than 4 and 4 is greater than 3 implies 5 should be greater than 3. So then only it is called as a transitive relation. So parallel to is also a transitive relation. Then greater than is also a transitive relation. Less than also we can use. Less than is also a transitive relation. Less than. Less than is also a transitive relation. For example, we can give 5 is less than 6. 5 is less than 6 and 6 should be less than 10 and 6 should be less than 10 implies what we have to write? 5 should be less than 10. 5 should be less than 10. It is also a transitive relation. Okay. 5 is less than 6 and 6 is less than 10. But is it right now? 5 is less than 6 and 6 is also less than 10. Implies 5 should also be less than 10. Then it is called as a transitive relation. Okay, you understood that? So today what we have discussed, first one is types of relations. Reflexive relation. What is the reflexive relation definition? Relation R on the set A is said to be reflexive if for all A belongs to A. You have to remember this statement. If for all A belongs to A comma A belongs to R. This is the definition of reflexive relation. For all A belongs to A comma A belongs to R. This statement is very important. Let us recall it, okay? What is reflexive? You better student write like this, okay, in the box. If for all A belongs to A comma A belongs to R. This is the statement of reflexive relation. Very, very important. Next one is symmetry. What is symmetry? For all AB belongs to A. AB belongs to R. AB belongs to R implies BA is also belongs to R. This is also very, very important. Students write like this. You put the box, okay, then you recall it whenever you get the free time, okay. Next one is transitive. So you have to recall it again and again. So this is very important. If you write the statement, you will get 1 mark, okay. So next one is for all ABC belongs to AB belongs to R and BC belongs to R implies AC belongs to R. So this statement is very, very important, okay. What is reflexive? For all A belongs to A, relation R and the set A is said to be reflexive if for all A belongs to A comma A belongs to R. You should know this statement, okay? Symmetry. The relation R and the set A is said to be symmetry if for all AB belongs to A comma B belongs to R implies B is also belongs to R. Next, transitive. The relation R on the set A is said to be transitive if for all A, B, C, here only one term element. Here there are 2 terms because it is reflexive now. A is related to A. So here we have to consider 2 elements A and B. And here A, B, C we have to take. Okay. If AB belongs to R and B is also belongs to R. In transitive, ABC belongs to A, we have to take ABC. AB belongs to R. Next we have to start from B. BC belongs to R implies AC belongs to R. This is very important. Okay? Very important. So next one is equivalence relation. What is the next one? Equivalence. Equivalence relation. The relation R on the set A is said to be equivalence. The relation R on the set A is said to be equivalence if it is reflexive, symmetric, and transitive. Equivalence relation is the relation R and the set A is said to be equivalence if it is reflexive, symmetric and transitive. All the three definitions should satisfy, all the three relations should satisfy. Then only it is called as a equivalence relation. Relation R and the set A is said to be equivalence if it is reflexive, symmetric and transitive. All these statements should satisfy. Then only it is called as an equivalence relation. We can give the examples. So many examples we can give. Which is the first examples? We can give parallel to no. Parallel to is an equivalence relation because A is parallel to A. A is related to A. The line is related to itself. Therefore, it is reflexive. Symmetric. A relation is symmetric because if A is parallel to B and B is also parallel to A, it is also a symmetric relation because the condition is going to be satisfied. What is transitive? Parallel to condition satisfies because A is parallel to B, B is parallel to C implies A is parallel to C. All these conditions parallel to is going to be satisfied in all the three definitions. Therefore, it is an equivalence relation. Okay, you understood? So, you should know it thoroughly. You have to practice it daily, these statements. For all A belongs to A belongs to R. For all AB belongs to A, AB belongs to R, BA belongs to R. Next, for all ABC belongs to A, AB belongs to R, BC belongs to R, implies AC belongs to R. This chapter is little bit what? You have to practice it, okay? You have to practice it thoroughly. Then only you can get easily the marks in the examination, okay? So students should write these statements. Student should write these statements. Okay, you have to be confident by taking this definition. Okay. Next, we solve the examples by using this. So, these are already came in the examination. These examples are already came in the examination. Repeatedly it is coming. We are going to solve this, okay? Relation R. Relation R in the set A is equals to 1, 2, 3, 4 up to 13, 14 defined as R is equals to xy such that 3x minus y is equals to 0. Find whether R is reflexive, symmetric and transitive. This is coming March 2015, repeatedly coming. In fact, is very important. So relation R in the set A is equals to 1, 2, 3, 4 up to 13, 14. So defined as R is equals to xy such that 3x minus y is equals to 0. Find whether R is reflexive, symmetric and transitive. So reflexive means AA should be R. AA should belongs to the set R. And symmetric, if AB belongs to R, implies BA should also belongs to R. Transitive, if AB belongs to R, BC belongs to R, implies AC belongs to R. These conditions should satisfy. Then only it is called as equivalence. This is equivalence relation. We have to check it for all the three relations. If it is satisfies or not, we are going to check it. Okay. So what is R? R is xy such that this one is such that. Okay. This condition is such that. You can put instead of xy, instead of this vertical line, colon, first year I have told you, such that it is also such that. We can use the terms whichever you want, you can use that. Okay. So 3x minus y is equals to 0 implies, so 3x is equals to y. Okay. We have to write the equation like this. So if x is equals to 1, what will be this equation becomes 3 of 1 is equals to y implies 3 is equals to 1 implies y is equals to 3. If x is directly you can write it in. If x is equals to 1, y is equals to 3 into 1 now, which is equals to 3. Next, if x is equals to 2, so 3 into 2, how much? 3 2s are 6, y is equals to 6. You can substitute the x value here. So 3x, 3 into 2, which is equals to 6 now. Next, if x is equals to 3, what will be the y value? 3 into 3, which is equals to 9. 3 3s are 9. Y is equals to 9. Next, if x is equals to 4, y is equals to 3 into 4. 4 3s are 12. Okay, so y is equals to 12. If x is equals to 5, y is equals to 3 into 5. 5 3s are 15. So, shall we take this value because it is not there in the set A? We couldn't take this y value because no, it is not there in the set A. So, up to here we have to take. Okay? X is equals to 4, y is equals to 2. We have to take up to here. If x is equals to 1, if x is equals to 1, y is equals to 3. If x is equals to 2, 3 2s are 6, y is equals to 2. If x is equals to 3, y is equals to 9. If x is equals to 4, y is equals to 12. Up to here we have to take because it is not there in the set A. So, what will be the R values? R. So, R is equals to, if x is equals to 1, what is y value? 3. 1, 3. If x is equals to 2, y is 6. If x is equals to 3, y is 9. If x is equals to 4, y is 12. So this is the R values. So we have to write the R value first by solving this equation. Okay. How to find that 3x minus y is equals to 0, 3x is equals to 1. So if x is equals to 1, if you put x is equals to 1, you get y is equals to 3. If x is equals to 2, y is equals to 6. X is equals to 1, y is equals to 2, 3, x is equals to 2, y is equals to 6, x is equals to 3, y is equals to 9, x is equals to 4, y is equals to 12. So by this relation R, we have to check whether it is reflexive, symmetric and transitive. So first one is reflexive. Is it reflexive? Reflexive means AA should be R. AA should belong to the set R. The same elements should belong to R. Is it there in the set R? For example, AA means it should be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Is it there in the set R? No, it is not there in the set R. So, R is not reflexive. R is not reflexive. Why it is not reflexive? Because 1, 1 does not belongs to R. You know the definition for this instead of this A belongs to A comma A belongs to R. You can change the variable also because it is there in the xy. No, you can use x belongs to A implies xx belongs to R. You can write like this also. This xx is not there in the set R, so therefore it is not reflexive. Okay. Is it R is symmetric? Is it R is symmetric? R is also not symmetric. Okay. If R is not symmetric, why it is not symmetric? So you know that you have to recall the definition. If for all xy belongs to R, according to this statement, xy belongs to R means yx should also belongs to R. If it is 1, 3, since 1, 3 belongs to R, but we have to get 3, 1 also. If 1, 3 belongs to R, we have to get 3, 1 should also belongs to R. Is it 3, 1 belongs to R? Is it any 3, 1 here? No, 3, 1 is not here. So it is not belongs to R. Since 1, 3, of course 1, 3 is there in the set R, but you don't have 3, 1 in the set R. Therefore it is not symmetric. Okay, it is not symmetric. It is not symmetric. Next one. What we have to check? R is transitive. R is transitive. Transitive, we have to check if AB, according to this, if xy belongs to R, yz also belongs to R, implies xz should also belongs to R. We have to check like this. Is R is transitive? For example, 1, 3 belongs to R and 3, 9. If I take this, 3, 9 belongs to R. Then what we have to write? This 1, 9 should also belongs to R. Is there any 1, 9 in the set R? 1, 3 is there in the set R. Of course, it is there in the set R. 1, 3 is there in the set R. 3, 9 is also there in the set R. Implies 1, 9 should also be there in the set R. Then only it is called as a transitive. It is not there in the set R. Therefore, R is not transitive. R is not transitive. You understood this one? This is very important. Actually, it is easy also. Okay, you have to practice it. Students need to practice 1 or 3 times. We have to daily write 3 times in each question. Like every year, you have to practice. Then only you can succeed in the examination. Okay, students, you have to practice it. Okay. Next examples. This is also important. Okay. Relation R on the set 1, 2, 3, 4, 5, 6 given by R is equals to AB such that B is equals to A plus 1. Find whether R is reflexive, symmetric and transitive. This is also very important. March 14th, 3 marks. Important question. You can see the question paper in the previous examples also, and B is equals to A plus 1 also. You can see the question paper so many times it is came, okay. So what is the equation? B is equals to A plus 1, okay. We have to find R, then we have to check it whether it is reflexive, symmetric or transitive. So if A is equals to 1, what will be B value? B is equals to 1 plus 1, which is equals to 2. If A is equals to 2, what will be B value? B is equals to 2 plus 1 is 3. If A is equals to 3, what is B value? B is equals to 3 plus 1, 4. If A is equals to 4, B is equals to 4 plus 1, 5. Shall we continue it? Shall we continue it? No. You will check it. This one also. If A is equals to 5, 5 is there, no? If A is equals to 5, B is equals to 5 plus 1 is 6. Up to here we can write the elements. Okay? We have to consider that equation because R is defined over the Cartesian product of AB such that B is equals to A plus 1, B is equals to A plus 1, A is equals to 1, B is equals to A plus 1, that is 1 plus 1 which is equals to 2. If A is equals to 2, B is equals to 3. If A is equals to 3, B is equals to 4. If A is equals to 4, B is equals to 5. If A is equals to 5, B is equals to 6. So we have to write the set R. We have to write the relation R. R is equals to, in terms of Cartesian product, A is equals to 1, B is equals to 2, A is equals to 2, B is equals to 3, A is equals to 3, B is equals to 4, A is equals to 4, B is equals to 5, A is equals to 5, B is equals to 6. Okay, correct is correct. By this we have to check whether it is reflexive, symmetric or transitive. First one is reflexive. Is it reflexive? I have already told the definition. What is the reflexive relation definition? For all A belongs to A should also belongs to the relation R. For example, reflexive, A is related to A, that is A is related to itself. 1 should be related to itself, 2 should be related to itself, 3 should be related to itself. Is it 1 is there in the set R? Is it 2 is there in the set R? Or 3, 4, 5, 6, 6. These are all not there in the set R. Therefore, it is not reflexive. Therefore, R is not reflexive. R is not reflexive. Since 1 does not belong to R, etc. Then write like this. You know the definition, no? For R A belongs to A should also belongs to R. We have to write this definition. Okay. Next, what we have to check? We have to check R is symmetric. R is symmetric. Is R is symmetric? Okay, is R is symmetric. So symmetric, if AB belongs to R, implies BA should also belongs to R. If AB belongs to R means BA should also belongs to R. Then only it is called as a symmetric relation. So if it is 1, 2 belongs to R, what we have to imply? 2, 1 should also belongs to R. 2, 1 should also belongs to R. Here is there any 2, 1? No, there is no 2, 1. in the set R. Therefore, it is not symmetric. If it is 2, 3 belongs to R, means 3, 2 is also belongs to R. That vice versa. If 1, 2 belongs to R, 2, 1 should also belongs to R. We have to see the definition. AB belongs to R or XY belongs to R implies BA should also belongs to R or YX is also belongs to R. Then only it is called as a symmetric. So it is not there in the set R, no, therefore it is not symmetric. R is not symmetric. You are following, no? Students are following. Next one, R is transitive. Is R is transitive? Let us consider it. 1, 2 belongs to R. And if it is 1 to what we have to take? 2, 3. 2, 3 should also belong to R. Then we have to go for 1, 3. 1, 3 belongs to R. Is there any Cartesian, that is order plane is there in the set R? 1, 2 is there in the set R. 2, 3 is there in the set R. But 1, 3 is not there in the set R. It is not there in the set R. So all the three, according to the transitive relation, if AB belongs to R and BA, BC should also belongs to R, implies AC should also belongs to R. Then only it is called as a transitive relation. AB belongs to R, BC belongs to R, implies AC belongs to R. Then only it is called as a transitive relation. For example, 2, 3. 2, 3 is there in the set R. And 3, 4. 3, 4 is also there in the set R. What it has to imply? What it has to imply? 2, 4. 2, 4 is also there in the set R. But it is not there, no. It is not there. Therefore, it is not transitive. Okay? These are the examples. Tomorrow, we are going to continue. In the next session, the 3 marks examples we are going to continue. Students write this each definition 3 times, each examples 3 times, at least 3 times. We have to get practice. Then only we can do it examination easily without any tension. So you have to practice drill work. You have to do. Previous year students used to do like this only. So the result is good if you do like this. Otherwise, result, I don't know what is going to be happen. Correct, no? Students, get practice, thorough it. So, I am sending these notes also. You have to practice it daily. You have to write it at least 3 times, each question. I am going to check it. Okay, thank you. Thank you so much.